So, exploring the universe has always been humanity's aspiration to understand the world beyond Earth. In that journey, humans have discovered important celestial objects in the universe, marking the pinnacle achievements of intelligence and surpassing human imagination. And recently, scientists have for the first time recorded the most intense battle in the history of the universe. After many years of studying the universe, experts have for the first time released images of what is considered the most intense battle within our galaxy. 7,500 light-years from Earth are two stars with mass and density considered the largest in our galaxy. This binary star system is called Eta Carina, surrounded by a nebula formed about 2 centuries ago. But why mention these two stars? It's because these two stars have been engaged in an extremely violent war for millennia. And now, for the first time after many years of astronomical research, experts have recorded detailed images of this most spectacular battle in the universe. This battle essentially involves these stars becoming explosive, with a frequency and density that is terrifyingly high. So much so that Eta Carina was once called a supernova imposter because the activity of the two stars is almost equivalent to an exploding star. For example, in 1837, a major explosion occurred here. The explosion lasted up to 18 years, illuminating everything in our galaxy. Experts say the reason is still unclear why this binary star system has such terrifying battles. It is only known that both are still generating winds full of gas and dust at speeds of up to 10 million kilometers per hour. The two stars in this system are Eta Carina A and B. Among them, Eta Carina B is the smaller star but still has a mass 30 times that of our Sun and is millions of times brighter. For Eta Carina A, the numbers are even up to 90 times and 5 million times brighter than the Sun. Every 5.5 years, the two stars move closer together, with a distance equivalent from Mars to the Sun, about 228 million kilometers. This is called the periastron, the point of closest approach. The most recent periastron occurred in August 2014. And fortunately, that was also when the European Southern Observatory, ESO, successfully installed the giant VLTI telescope to observe this phenomenon. Until recently, the first image of the collision was released. The image is not very clear but sufficient to officially confirm that there is a very intense and fierce battle on Eta Carina. In general, each star within this binary system is capable of releasing extremely powerful molecular winds, raising temperatures to 50 million degrees Celsius. Dust and gas winds from both sides have formed a dumbbell-shaped nebula surrounding both stars. Although sharp images are not possible, this is a unique opportunity to gather more knowledge about Eta Carina, as well as similar objects in the universe. In the future, this may become one of the valuable documents for experts to understand the reasons behind one of the largest explosions in the history of our galaxy. And also recently, one of the most intense explosions in the history of the universe was just discovered. So violent that it created a giant hot gas sphere that could contain 15 of our galaxies. The explosion originated from the center of the galaxy cluster in the constellation Ophiuchus, 390 million light-years from Earth. Basically, galaxy clusters are the largest structures known in the universe, containing thousands of galaxies bound together by gravity. The explosion originated from a supermassive black hole at the center of a galaxy in the Ophiuchus. It is known that the first information about this giant explosion appeared in 2016. The Chandra X-ray telescope captured an unusual curved edge in this galaxy cluster. However, scientists at that time ruled out the possibility of such a large hot gas explosion. After a period of comparing data from 4 observatories, scientists officially confirmed that the curved edge is indeed the result of a giant explosion, breaking all previous records. According to a statement by astronomers in the Astrophysical Journal by Dr. Joe Fischella, this is the most intense explosion recorded in the history of the universe since the Big Bang. Even the energy released from this newly discovered explosion is 5 times greater than NSO 735 plus 74, which was previously known as the largest and most destructive explosion in the universe. Its power is so great that it created a hot gas sphere capable of containing 15 galaxies. Astronomers conducted this observation using telescopes on the ground and in space. X-ray data combined with radio wavelength data from ground-based telescopes helped astronomers confirm the existence of the cavity because it borders an area without radio emissions. These emissions are generated by electrons moving at the speed of light inside the pre-energy jets emitted from the black hole. Why do some planets have rings surrounding them? Since ancient times, it was believed that Saturn was the only planet in the solar system with rings. But it turns out that's not the case. The rings surrounding Saturn were discovered by the astronomer Galileo Galilei nearly 400 years ago. He used a very simple telescope that he assembled himself from various lenses, then pointed it toward the planets in the night sky. One of the first objects he saw was Saturn. Initially, he thought Saturn had two large moons on either side of the planet. Because his telescope wasn't very good, it only produced very blurry images. Since then, astronomers who study the universe and everything in it, like planets and stars, have used larger and better telescopes to find rings surrounding the giant gas planets like Jupiter, Saturn, Neptune, and Uranus. These planets are not like other planets in our system. They are primarily composed of gas. We still don't fully understand how the rings surrounding these planets operate, or how they were formed. But there are some hypotheses as follows. The first hypothesis says that the rings formed at the same time as the planet. As formation were too far from the planet and could not be pulled together by the gravitational field. Therefore, they remained in space and formed the ring system. The second hypothesis is that the rings formed when two of the planet's moons, which formed at the same time as the planet, for some reason encountered orbital issues and eventually collided. The remnants from this catastrophic collision could not recombine to form a new moon. Instead, they scattered in space and formed the ring systems we see today. Since no one knows the exact answer, we must continue exploring and testing various hypotheses. What we do know is that the rings around different planets vary slightly from one another, but they also share some common features. First, they are much wider than they are thick. For example, Saturn's rings are about 280,000 kilometers wide but only 200 meters thick. Another thing is that all ring systems are composed of small ice and rock particles. The smallest particles are the size of dust grains, while the largest are about 20 meters in diameter, roughly the size of a schoolyard. All rings around planets also have gaps that can sometimes be several kilometers wide. Initially, no one knew why these gaps existed, but later we discovered they are caused by small moons that have cleared all the material in that area. S rings and those of other gas giants is that the particles making up Saturn, meaning they appear very bright, explaining why we can see these rings from Earth with just an ordinary telescope. The number of particles in Saturn's rings is also extremely large, making these rings much bigger and wider. That is another reason they are more noticeable than the rings of other gas giants. The particles making up the rings of Uranus and Neptune contain elements that turn dark when sunlight shines on them. These dark particles look very much like the color of coal or charcoal you use for a fire, making them very difficult to see, because they do not reflect sunlight toward us like Saturn's rings do. The latest research provides evidence that Mars once had a material ring surrounding it, so what happened to that ring? New evidence is hidden in the moon Deimos, the smaller of Mars' two natural satellites. Deimos orbits Mars with a slight tilt relative to the planet's equatorial plane. This tilt could be the result of gravitational influence from a material ring. Some scientists hypothesize that Mars also had a material ring in the past. They performed simulations on the moon Phobos, the larger moon of Mars, and discovered that it could have formed from the result of an asteroid collision with Mars. The debris ejected into space gradually formed a ring, and from that, Phobos emerged. Now, scientists are also studying the moon Deimos, and the results obtained align with previous analyses. Orbit not lying in the same plane as Mars. However, when these scientists came up with a new idea and observed this phenomenon from a new perspective, they realized that Deimos' orbital deviation reveals many mysteries. Orbital tilt is not large, only 1.8 degrees relative to Mars. Deimos takes 30 hours to complete one orbit around Mars, with an almost circular orbit. Meanwhile, Phobos is different. This satellite is closer to Mars and takes only 7 hours and 39 minutes to complete one orbit. Moreover, each year Phobos moves 1.8 centimeters closer to Mars. At this rate, within about 100 million years, Phobos can cross the Roche limit, the minimum safe distance from Mars. When it crosses the Roche limit, Phobos will be torn apart by Mars tidal forces. Most of the debris will form a rain, while some fragments may become smaller satellites. Studies suggest this phenomenon may have occurred multiple times in Mars history. Thank you for watching the video.